Hi, hello. So we are going to work on trigonometric identities. So this is going to be the start of my all-time favorite pre-cal unit, which for many of you, this is going to be the start of your villain origin story. So hopefully you don't hate me too much after this unit, but just saying, this is my personal fave. So we're just going to dive right in. So we're going to bring back this little chart that we had before when we first started introducing trig. So we're going to be given this fancy little sketch over here to the right where we have some radius given in our circle. And then with that radius, we're going to have some horizontal component and then some vertical component to that radius. So we're going to kind of just go back and do like your geometry trig ratios using like SOHCAHTOA and all that. So we're going to assume that your R value, that we're working in the unit circle, so we're going to work with a radius of 1. So I'm actually going to say that this radius here is going to be 1, but we're going to fill that in kind of as we go. So starting off, so we're going to be doing sine, cosine, and tangent of these values. So if I reference my angle here, remember this would be your opposite, then your hypotenuse, not hypotenuse, hello, still early in the morning, y'all. This is your adjacent, and then your radius, this is going to be your hypotenuse. So when I do sine, that's going to be your opposite over the hypotenuse, which is going to be your y value over your r value, which is your radius. Your cosine, in this case, would be your x value over your hypotenuse, which is r. And then your tangent value would be your y value over your x value. Then if we move over to cosecant, secant, and cotangent, so remember cosecant is your reciprocal of sine. So we're just going to take your ratios that we have in the left-hand side, and we're just going to flip them for the right-hand side. So now for cosecant, this is going to be the hypotenuse over the opposite, so your r value over y value. For secant, we're looking at the hypotenuse over the adjacent, which is going to be your x value. And then for cotangent, we're going to have the adjacent over the opposite. So this is just going to be your general ratios based on that sketch, but now I want to fill in these same ratios based on a radius of 1. So what this tells me is that all of my r values are going to now just go to 1. So what we're going to write over here is now this is going to turn to y over 1, which is going to be equal to y. Then we're going to have x over 1, which just turns to x. And then, well, this one doesn't change at all, so it's just going to stay how it is, but we love tangent. All right, and then over here, your cosecant's going to turn into, it's going to turn to 1 over y. Your secant value is going to turn to 1 over x, and then cotangent, once again, is just going to, it doesn't get anything special. It's okay. So what we're going to focus on specifically is what your x and your y values are. So if you look, your x value represents the horizontal, your y value represents your vertical. So back when we first learned about the unit circle, hopefully that's where you remember that all your x values correspond to cosine of a value, all your y values correspond to sine of a value. So now we're going to use that logic to kind of build upon and do what we call the Pythagorean theorem. So with the Pythagorean theorem, we know it, well, as a squared plus b squared equals c squared, but I'm going to relate it specifically to this image. So I'm going to do my x squared plus y squared equals r squared. So that's what I'm going to start with here. So x squared plus y squared is going to equal r squared. Now I'm actually going to plug in values for those x, y, and r values. So more specifically, the x and y is going to be replaced with sine and cosine. And then over here, your r value is going to be replaced with 1. So my x value is going to be changed to cosine theta squared. And then my y value is going to be changed to sine theta squared. And then that's going to be equal to the radius squared, which is 1 squared. So how you're going to rewrite this is going to be cosine squared theta plus sine squared theta, and that's going to equal 1. So this is one way to write what we call an identity, but the way that you're most commonly going to see it written is we like to write sine first. I don't know why, but we just go with it. But it's tomato, tomato. It's still all the same. So you're going to see it mostly written as sine squared theta plus cosine squared theta equals 1, but you could also see it written as cosine squared theta plus sine squared theta equals 1. Tomato, tomato, it doesn't matter. Now, this is your big identity right here. So when I say identity, it's going to represent some sort of equation that we can use to manipulate other equations. So this identity here is so important that I give it a very special little name. So I call it Big Papa, because we gonna use this equation for a lot. So that being said, we're going to be using equations for other equations. So think of it like a puzzle for identities. So that being said, to work our way into it, we're actually going to do this little riddle. So we want to turn the word boy into the word man by only changing one letter at a time. Each time a letter is changed, the letter should still create an English word that you can find in a dictionary. So as we start off, we also want to discover if there's only one way to do this. So we're going to start off with the word boy. So I'm going to do this vertically, or you can do it horizontally. It's up to you. So boy, what I can do is I can change boy. I can change it to bay. So this would be B-A-Y. And then after bay, I can turn this to may. So M-A-Y. And then after may, then I can switch the Y to an N. So now it becomes man. So we started with the word boy, and then we ended with the word man. So we did that by alternating and manipulating this word a couple times to change it into something else. So this is essentially what identities are doing. So I want you to kind of pause here and actually see if you can do the same thing that I just did over here, but see if there's another sequence. So there is another way. So what I'm going to start with is, well, obviously we're still going to start with boy. But the other way you can do it, so I'm going to change boy still back into bay. And then you can actually change bay into ban. So B-A-N. And then ban, you can hello. English is hard. Then you can turn ban into man. Ta-da. So there's a couple different ways that you can do it. So this is kind of the whole premise of identities, is there may be more than one way to do a specific problem. So diving right in, we're going to look at our first set of identities, which we refer to as reciprocal identities. So we've actually seen these before. We're just going to kind of put a name to it. So whenever you have 1 over sine theta, this is the same as writing cosecant theta. If I have 1 over cosine theta, this is the same as writing secant theta. If I have 1 over tangent theta, that's the same as writing cotangent theta. And then over here, now we're going to do a reciprocal of the reciprocal. So I'm actually going to do this one off to the side just to kind of show you what we're doing. So if I have 1 over cosecant of theta, this is the same as doing 1 over sine theta. And when I divide by a fraction, that's the same as multiplying by the reciprocal. So 1 times sine theta over 1, which is sine theta. So we're going to go back to the original, essentially. So over here, if I have 1 over cosecant, that's the same as writing sine theta. So same idea, if I have 1 over secant, that's going to be cosine theta. And then if I have 1 over cotangent theta, that's going to be equal to tangent theta. So here are 6 reciprocal identities. So now we're going to add 2 more. Now we're going to add in now we're going to add in the quotient identities. So your quotient identities are going to be your sine over cosine, which we know this as tangent theta. And then over here we have cosine theta over sine theta, which hopefully we know as cotangent theta. So now we have a total of 8 different trig identities that we can use to manipulate. So down here we have 6 little practice problems that we're going to simplify. So first off, we have sine of x times cosecant of x. So what you want to really focus on is get everything in terms of sine and cosine. So what I'm going to do is I'm going to leave my sine alone, but I want to change my cosecant. So this is going to be rewritten as sine of x times 1 over sine x. So notice if I were to kind of rewrite my sine x over here on the left side, that's going to be sine x over 1, which when I rewrite, this is going to be equal to sine x over sine x, which when I simplify, that's just going to be equal to 1. So your answer here is just going to be 1. Whoops. Now number 2. So now I've got tangent x times cosine x. So I'm going to turn tangent x into sine x over cosine x. And then cosine, I'm going to leave it alone. So that would be cosine x over 1. So now notice how we have cosine in both the top and the bottom, so those can simplify. So when I simplify, all I have left is just sine x. So notice how on these first two problems, how with fractions, we know that we could technically cross these values out and simplify, but with identities, you don't ever want to cross anything out. You just want to kind of eye it. If it helps to kind of do like a really thin line, then maybe, but notation-wise, you really don't want to cross anything out because that technically changes the problem. So we want to leave everything as is. You don't want to cross anything out, which I know is going to be annoying, but, well, that's the math world for you. So the next one we have is going to be tangent theta times cotangent theta. So also notice how your variables might change. So up here we dealt with x, down here we're dealing with theta, and then over here we got the letter t, and then if you look around, I think the rest of these are just, oh yeah, then we got the letter u over here. So just pay attention to whatever variable we're using because you have to stay consistent with whatever variable is being presented to you in the problem. So if I've got tangent theta equals cotangent theta, so I'm going to change tangent to sine theta over cosine theta, and then cotangent is going to be rewritten as cosine theta over sine theta. So we've got sine in both the top and the bottom, so those would simplify, and then we have cosine in the top and bottom, so those would simplify. So then what you're left with is just 1. So these are not always going to simplify to just 1. Sometimes they do, sometimes they don't, but oftentimes they're mostly going to simplify to some sort of trig ratio. Now looking at number 4, so now we've got sine t times secant t times cotangent t. So over here, I'm going to leave the sine t alone. I'll write it over 1 so we can clearly see our fractions. Secant is going to be 1 over cosine t. And then cotangent is cosine t over sine t. Okay, so as you can see, we have a sine t, so those will cross out. And then we also have cosine t in the top and bottom, so those would cross out. So all we have left is just 1 over 1, which is 1. So, wow, 3 out of the 4 are just 1. I promise, not all of them are going to be 1. Looking at this next one, so now we're going to kind of throw in some exponent curves at you. So what this means is that we're going to have 2 of those cosine values. So I'm going to rewrite it as cosine squared x. And then cosecant is going to be 1 over sine x. And then secant x is going to be 1 over cosine x. So what's going to happen here is, remember, this cosine squared x, this means that there's going to be 2 in the top, but I have 1 over here in the bottom. So when I simplify, one of the cosines in the top is going to cross out and simplify, and then the cosine in the bottom is going to simplify, which means we only have 1 cosine in the top, and we still have a sine x in the bottom, which means cosine x over sine x, that's going to simplify and become cotangent x. Now number 6. So now we've got sine x over tangent x. So tangent x is going to simplify to sine x over cosine x. So once again, as you remember, if I am dividing by a fraction, multiply by the reciprocal. So this will turn to sine x times cosine x over sine x. So now I've got a sine x in both the top and the bottom, so those can simplify. So all I've got left in this case will be cosine x. So just know that for day 1, we're trying to keep these somewhat pretty, somewhat nice. We don't want to go too heavy on the first day. So moving on, now we're going to work on the next set of identities. So now we're going to introduce what we call Pythagorean identities. So we're going to use Big Papa twice, and we're going to develop 2 other identities. So notice how we have sine squared theta plus cosine squared theta equals 1 on both the right and the left side. So what's going to happen is we're going to use Big Papa, and we're going to develop 2 other very important identities. So on the left side over here, what I'm going to do is divide everything by cosine squared theta. And then everything over here on this side, on the right side, also by cosine squared theta. So when I do that, that's going to simplify to give me sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta. And that's going to equal 1 over cosine squared theta. So when I simplify, this is going to turn into tangent squared theta plus 1, and that's going to equal secant squared theta. So this is another really big important identity. Now this is developed directly from Big Papa. Now same idea over here, we divided both sides by cosine squared theta, so take a gander. What do you think we're going to divide by on this side? Hopefully you just said sine squared of theta. Okay, so I would actually pause here and actually try to simplify this one and see if you can kind of discover what the next identity is going to be. So try this one on your own. So when you divide everything by sine squared theta, this should be what you get so far, and then you're going to simplify. So this is going to leave you with 1 plus cotangent squared theta equals cosecant squared theta. Ta-da! So here's another one. So a lot of people, in the past, when I've taught this before, what a lot of people end up doing is they get some of these values mixed up. Like they'll put cosecant instead of secant, and then like secant over here, or they put tangent over here. So the way that I kind of remember it is I remember that C and C go together. Cotangent, cosecant go together. Whereas over here, it's just tangent, secant, but I use the two C's as my kind of reminder that they go together. Now, with that, now we've got even more identities. So we've got Big Papa, and then we use Big Papa to develop these other two identities. So now we have these 3 big identities, which are our Pythagorean identities, in addition to your reciprocal identities and your quotient identities. So in total, now we're up to 6, 8, 11. And now we're actually going to get even more identities, because now there's going to be variations of these 3 Pythagorean identities. So I will say this part right here is going to be super important, because all the variations are going to pop up, and you may not even realize that they pop up. But I cannot stress enough how important knowing your variations are. So starting off, so essentially what's going to happen, what we're going to do, is we're going to solve for each component of your identity. So we already have it solved for 1. So now for the first identity, or variation of Big Papa, now I want to say, let's solve for sine squared theta. So if I solve for sine squared theta, that's going to be equal to 1 minus cosine squared theta if I were to subtract cosine on both sides, which, here, let me actually write this out. This is not something I want to skip over lightly. So we're going to start from the beginning, and then I'll skip some steps later. So what's happening is I'm going to go ahead and just subtract cosine squared theta on both sides. So when you subtract on both sides, we get sine squared theta equals 1 minus cosine squared theta. So this is going to be one variation. And then we're going to do another variation. So I'm going to repeat the same process. So sine squared theta plus cosine squared theta equals 1. So we already solved for sine squared theta. Now I want to solve for cosine squared theta. So now, once again, now I'm going to subtract sine squared theta on both sides. So when I subtract on both sides, that's going to leave us with cosine squared theta equals 1 minus sine squared theta. That's a 2. So this is another variation that you're going to have. So for each of your identities up here, there's going to be 2 corresponding variations that are going to come with it. Now over here, same idea. So I would say pause here, take another few minutes, and actually develop the other 2 identities or variations that come with these identities. Try not to have an identity crisis. Ha, 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 knee slap. Hopefully you're having a great day so far. If not, I'll make it better with some pre-cal. I'm pretty sure y'all are mentally throwing a desk at me right now, but you know what? It's okay. Because math is hard. All right, I'm going to go ahead and get started. So over here, now I'm going to find the other variations. So before, or up in these identities, we have secant squared theta, and we have cosecant squared theta solved. So now I'm going to solve for the other components in our identity. So for this first one, I'm going to solve for 1. So I'm going to subtract tangent squared theta. So over here, this is going to be 1 is equal to secant squared theta minus tangent squared theta. So here's another important variation. And then down here, now we're going to solve for tangent squared theta. So I'm going to subtract 1 on both sides. So it's tangent squared theta equals secant squared theta minus 1. So here's another variation. Ooh, I didn't write it in blue. Whatever, it's fine. Okay, now same idea over here. So I'm going to take this equation. So we already have cosecant squared theta solved. So now I'm going to solve for 1 in the first one and then solve for cotangent squared theta in the second one. So solve for 1, so subtract cotangent squared theta. So this is going to leave you with 1 equals cosecant squared theta minus cotangent squared theta. So here's another variation. And then for this last one, now we're going to solve for cotangent squared theta, so subtract 1 on both sides. And then this is going to leave us with cotangent squared theta equals cosecant squared theta minus 1. So now we have even more. So hopefully you're not crying yet, but it's okay. It's only day 1. Remember, we have many days of identities. So identity crisis is probably going to be the theme for the next few weeks. So starting off, number 1, now we're going to use even more identities to kind of help us develop and simplify these. Not really develop, but simplify. So my big advice for you is really focus on getting everything written in terms of sine and cosine. So the cosine squared x, I'm going to leave alone. The sine x, I'm going to leave alone, but I want to change my tangent. So I'm going to rewrite this as cosine squared x times sine x over cosine x. And then that's going to be all over sine x. Now, a quick note, you have to include your variables with your trig functions, your trig ratios. If you fail to write your variables, that is improper notation, which means that's points off per variable you forget. So for example, if you write just cosine squared tangent over sine, where are your variables? How dare you? That's improper notation. I would be very sad. You hurt my feelings. How dare you? And because you hurt my feelings, I'm going to take off 50,000 points. Because I can. Just kidding. But yeah, please don't forget your variables, because that is just part of your notation. So you have to include it. I will say on the AP test, if you don't put your variables, you're automatically losing the point, even if you did it right. So that being said, let's simplify. So over here, we have a cosine squared theta, nope, not theta, a cosine squared x and a cosine x right here in the bottom. So I'm going to simplify and rewrite this as just cosine x, just one of them, since we lost one, times sine x, and then that's going to be all over sine x. And then what's going to happen, we have a sine x and a sine x. So those are going to cross out, and we are left with cosine x. Sad face. All right, number 2. So we're going to get everything rewritten in terms of sine and cosine once again. So cosecant, I'm going to change this to 1 over sine times sine x, and then minus cosine squared x. Now we have sine x times 1 over sine x, so those are going to simplify to just 1. So 1 minus cosine squared x. And then hopefully you kind of recognize this variation. 1 minus cosine squared x is a variation of Big Papa. So 1 minus cosine squared x is the same as sine squared x. So down here, oh no, my Apple Pencil, is just going to be sine squared x. Now, number 3. So, oh, this one looks gross. So I'm going to focus on simplifying the inside first. So I'm going to rewrite this as cosine theta, and then secant is going to be 1 over cosine theta, and then cosine theta, and then cosecant squared theta is 1 over sine squared theta. So I'm going to put sine squared in the bottom. Now I'm going to distribute that cosine theta. So when I do that, that's going to leave us with cosine theta over cosine theta, and then that's going to be plus cosine squared theta over sine squared theta. Okay, and then this is going to be 1 plus, and then cosine squared theta over sine squared theta is going to be cotangent squared theta. And then 1 plus cotangent squared theta, that is going to be one of your fancy little identities over here. So 1 plus cotangent squared theta is cosecant squared theta. So that's part of your Pythagorean identities. So 1 plus cotangent squared theta is going to be cosecant squared theta. Gross. Number 4. Now, over yonder, so now we have 1 plus cosine x and 1 minus cosine x. I'm going to distribute everything, so I'm going to do a double distribution. So the first terms, the outside terms, the inside terms, and the last terms. So essentially you're going to FOIL it. So I'm going to do 1 minus cosine x plus cosine x, and then minus cosine squared x. And then what's going to happen, your minus cosine x and plus cosine x, those are going to zero out. So we're left with 1 minus cosine squared x, which that's a Pythagorean identity that is going to simplify to sine squared x. Next. All right, I would actually recommend pausing here and at least trying number 5. Number 6 is a little spicy, but at least try number 5 real quick. Welcome back. All right, so let's do number 5. So I'm going to do sine t plus, all right, cotangent, I'm going to change to cosine t over sine t. And then cosine, I'm going to leave it alone. So what I'm going to do is I'm going to multiply the cosine t and cosine t. So that's going to change it to cosine squared t. So this will be sine t plus cosine squared t over sine t. Now, in order to add these, I need a common denominator, because right now I just have sine t over 1 plus cosine squared t over sine t. So I need a sine t in the bottom and a sine t over here in the bottom. So the expression on the right side is good to go, but I need to manipulate the left side. So what I'm going to do is I'm going to have sine t, and I'm going to multiply by a funky form of 1. So think about rationalizing, kind of the same idea as rationalizing. So I'm going to multiply by sine t over sine t, and then I'm still adding cosine squared t over sine t. So what's going to happen is now I'm going to multiply sine t and sine t, and then that's going to become sine squared t over sine t, and then plus cosine squared t over sine t. And now that I have a common denominator, I can add these together. So now I have sine squared t plus cosine squared t all over sine t. And then right here, this is Big Papa. So Big Papa is going to turn into just 1. So that's going to be 1 over sine t. Now 1 over sine t is the same as cosecant t. Ta-da! Number 6. This one's a little gross, but it's doable. So we've got cotangent u minus sine u cosine u all over cosine squared u. So with this one, I still want to get everything in terms of sine and cosine. So that's what I'm going to do first. So I'm going to draw my obnoxiously long fraction bar. So cosine is going to turn to, not cosine, cotangent is going to turn to, go away. Cosine, let's try this again. Cosine, no. Okay, let's try this one more time. Cotangent is going to turn into cosine u over sine u, then minus sine u cosine u. And that's going to be over cosine squared u. Now, similar to the previous problem, what we need is we need this part over here to have a common denominator. So I need to multiply this by sine u over sine u. So because I am a lazy mathematician, copy and paste. So I'm going to multiply the top over here by sine u over sine u. I'm going to extend my obnoxiously long fraction bar. Not copy. Okay, and then this. So I'm going to leave that first part alone. So we're still going to have cosine u over sine u. And then this is going to be minus. So when I multiply over here, what's going to happen? Sine u and sine u is going to turn to sine squared u. And then we're going to leave the cosine u alone. So we're going to have sine squared u times cosine u over sine u. Then all over cosine squared u. So now that we have a common denominator here, now I'm going to combine those fractions. So another obnoxiously long fraction bar. So we're going to have cosine u minus sine squared u, cosine u, all over sine u. And then that's going to be all over cosine squared u. All right, now for the next step, what I'm going to do is I'm going to kind of just rewrite this entire fraction. So I'm going to kind of move it down. Essentially, I'm going to move it to the side. So I'm going to kind of visually move everything around, but I'm still going to rewrite it in a second. So I would hold off on writing what I'm about to do. So what I'm going to do is I'm going to move essentially this entire numerator, move it off to the side, and then replace it with a 1. That way you can kind of see a clear numerator and a clear denominator. So that's what I'm about to write. Okay, so now I'm going to have cosine u minus sine squared u cosine u over cosine squared u times sine u. So now what I'm going to do next is in the numerator, if you look up here, I'm going to now take out a greatest common factor. So what's in both of these terms that I can take out? Well, hopefully I can obviously take out a cosine u. So that's my next step. Okay, so when I take out that cosine u, that's going to leave us with 1 minus sine squared u. Hopefully you recognize that's one of your Big Papa identities, and that's going to be over cosine squared u times sine u. Okay, so now I'm going to manipulate the 1 minus sine squared u. That's going to turn into cosine squared u. So what's going to happen is we're going to have cosine u times cosine squared u, and that's going to be over cosine squared u times sine u. And then what's going to happen, we have a cosine squared u over cosine squared u. Those are going to cross out, or simplify rather, not cross out. So we're going to be left with cosine u over sine u. And then when you simplify that, that's going to equal to cotangent u. Cotangent u, not me. Ha, 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 ha. So, yeah. Hopefully you can probably see why identities can be a little ugly, but overall, I actually really enjoy them. They're just like puzzles. Think of it like the Rubik's Cube of math, which I'm pretty sure that makes y'all probably hate this even more. But ta-da! Hopefully you're not crying. Don't forget your letters or your variables. Otherwise, minus 50,000. Have a great day.